Hello, my name is Ishita Nargis. I'm doing a teaching demonstration. The topic of my teaching demonstration is merge sort. Here is the plan for the talk. At first, I will describe the technique that we use for designing merge sort algorithm. Then I'll describe the algorithm in detail, and finally, I'll talk about the time complexity of merge sort algorithm. So the technique or the design paradigm that we use for merge sort is called divide and conquer. It is an algorithm design paradigm. There are many problems that we encounter that can be solved recursive way, like calling recursive functions. Those type of problems we can design algorithm using the divide and conquer paradigm. So how does it work? It works by following a three-step process. In first step, the first step is called divide. Here we divide the problem in hand into smaller sub-problems of the same type. So if we have a bigger problem, then we break it into smaller problem. And the second step is called conquer. Here we actually solve the smaller sub-problems by recursive call of the original function. And the third step is called combine. In this step, we already have solutions for the smaller subproblems. Using the solutions of smaller subproblems, we um, create a solution for the original problem in hand. So now we go for merge sort algorithm. So merge sort is a sorting algorithm, and it is designed using the divide and conquer paradigm. So initially for an array of size n that runs from index 0 to n, it is called with the full array. But in general case, because it is a recursive algorithm, we can think that it runs from the index from P to R. So it is actually applies for an array or a sub array from location P to R, and at each step it actually calls a smaller subproblems recursively. And any recursive function, we have to have a terminating condition. In this case, terminating condition, when you have an array of size 1, then you don't have to do any sorting at all. So the condition is P equals R. So how do we apply divide and conquer for merge sort algorithm? In the divide step, we have an array from position P to R. So suppose the size of this array is n. Then we break the array into two uh, smaller arrays of size n by 2. We divide it into smaller sub arrays. So those two instances are independent, and each of them have size n by 2. So for this, we actually compute the middle index by taking the average of P and R. Suppose that middle index is Q. So the left array will be like from position P to Q, and the right array will be from position Q plus 1 to R. In conquer step, we recursively call the merge sort algorithm on position P to Q and for positions Q plus 1 to R. And in the combine step, we already have a sorted array from position P to Q, and also another sorted array of from position Q plus 1 to R. Using those from those sorted smaller arrays, we will construct a sorted array from position P to R. For this, we may need to like shuffling or rearrangement of elements depending on the values of elements in those two sub arrays. So the algorithm merge sort algorithm, this merge sort is the recursive function. So it runs from position P to R, and first we have the terminating condition. If P is greater or equal to R, that means we have size 1 or size 0 element, or maybe the index actually goes to the right, and that means that is invalid combination of in indices. So in any cases we return. So there is no more, this is the terminating condition for the recursion. And otherwise we compute the middle index Q, that is the average P plus R by 2, and we take the floor of this one because we have to have integer index. We could also use the ceiling of P plus R by 2, that is also possible. And then we recursively call merge sort from position P to Q, and also call the merge sort recursively from position Q plus 1 to R, and then we have already solved instances. After that we call the special function called merge, that is the process for step 3 combined, that is that will combine those solutions into a sorted array from position P to R. Next we go for the merge function, where we already have sorted arrays from position P to Q and also from position Q plus 1 to R. The output will be an array from position P to R that will be sorted. So first we count the number of elements in the left subarray that will be running from P to Q. So the number is Q minus P plus 1, and the number of elements in the right array is R minus Q, because it runs from position Q plus 1 to R. Now since these smaller sorted arrays are already they are sorted in the original array A, and next we will be sorting the array in its position in the original array A. That means we need to copy the original sorted array into other local arrays. We'll create new arrays and copy those things, and because there will be like elements will be transferred and moving around, so that's why we need two different arrays. So the L denotes the left array, it runs from position 0 to NL minus 1, and the R denotes the array for the right one from position 0 to NR minus 1, and then we copy all the elements in the sorted from position P to Q to the left array, and then we copy the elements sorted from position Q plus 1 to R into the right array. Next we already done copying. Then what we do, each will have like we'll consider each of those sorted arrays from position left to position right, that means from lowest to the right, the highest values, and at each iteration we will consider the current value and check which value is the smaller out of these two arrays, and take the smaller one and copy that into the final sorted array. That's the main idea. So there will be three index variables for like position. For the left one it will be the index variable is I, it runs from 0 to NL minus 1. For the right one it will be variable J from 0 to NR minus 1. So we initialize both of them to 0 because we start from the leftmost or the lowest ones. And for the final array where I will be copying, it will be running from position P to R, so we initialize that index variable K to P. Now we'll have a while loop that will consider all elements in the array. So the condition it will be this loop will be continued when we still have like continued if we still have one of the array, left array or the right array, is not run out of numbers. So we have this condition while I less than NL and J less than NR. I less than NL means there are still some elements in the left array, and J less than NR means there are still some elements in the right array. If one of them just runs out of numbers, then the AND condition is not will be satisfied. So in that case we come out of this while loop, and we consider the current variable, and position I is Li. If it is less than Rj, the current position in right array, then this is the smaller value. We copy at current location for copying, and we increment that index variable by 1 because we already copied 1 from that array. Otherwise this Rj is the smaller one, so we copy Rj to the current position in the final array and increment this index variable because you copied 1 from there. And in any case we have copied 1 element, so the index variable K is always incremented by 1. And when we are done with that loop, that means one of the array is run out. If I is less than NL, this condition is satisfied, that means the right array was actually finished. J was equal to NR. So there are still some elements in the left array and they are sorted. We just copy the sorted array by sequentially to the final array. And otherwise if that is not the case, that means I equals NL. In that case the right array is the there are still some elements, so we copy them sequentially to the final array. And if we consider the time complexity of merge, the main while loop runs at most n times, and the other while loops run at most n by 2 times. So the overall time complexity is big theta of n. And for the merge sort, the recursive function, if Tn denotes the time complexity of merge sort on an input array of length n. For length 1, it is a constant c1. Otherwise, for the size n array, we break into two smaller sub arrays of size n by 2 and then call each of them. So it will be 2t of n by 2, plus we have the merge sort, not the merge sort, actually the merge that has complexity big theta of n. So overall 2tn by 2 plus theta n, and the solution of this recurrence relation is n log 2n. So that is the time complexity of merge sort algorithm. Okay, so that's it. Thank you.